Okay, so hello people. So today we'll be solving LeetCode daily question 1235, that is maximum profit in job scheduling. And in this we'll be having n jobs where every job is equal scheduled to be done from start time I to end time I, and which will obtain us a profit of profits I. Okay, and in this we are given the start time, end time, and profit arrays, and we have to return the maximum profit. You can take so that there are no two jobs in the subset with overlapping time arrays. That means that if one job is taking the time from 1 to 3, we cannot pick up a job that starts at 2. Okay, and if we have a job x that ends at time x, we will be able to start another job at time x. That means if we are having a job that is like from time 1 to 3, so the next job we can pick is from 3 to somewhere else, 3 to some end time. Okay, so this is a dynamic programming question. As you can see that we have to check all possible ways, and at then we have to return the maximum from it. Okay, so now first let's have the length start, and all three these arrays will be of same length. Okay, length, and then what we do, let's have a job array where we'll be storing all these things in just one array. So it will be a 2D array that will be equal to new int of size n and 3, because there are only three things to show. So now let's start traversing these array. I equal to 0, I less than n, I plus plus, and let's first update the job array. Okay, so job 0 will be equal to start time. Oh, job I 0 will be equal to start time I, and job I 1 will be equal to end time, basically end time I, and job I2 will be equal to profit I. Okay, so now we have updated the job array, and now let's sort this job array based on the end time, because the lesser the end time, the more number of jobs we'll be able to do, and the more will be the number of profit. Okay, so arrays dot sort job array with the comparator as job comma a minus b, which will be an array, and here we will have to sort them on basis of a1 minus b1. Okay, and then what we'll do, let's do arrays dot sort. We'll also sort the start time, array start time. Okay, and now let's have a dp array where we'll be storing all the results in dp is equal to new int of size n, and then let's fill this dp array arrays dot fill dp comma -1. Okay, so now let's find call the function solve with the parameters as the starting index. Then what we'll be doing, we'll be passing in the job array, then the start time array, the size of the array, and the dp array. Okay, so now we'll write private int solve. It will take parameters as index, and the job array, job, the start time array, and start time, and the dp array, dp. Okay, so here we'll be checking that if I becomes out of bound, index greater than or equal to n, we'll be have to return 0, because that's not a possible job. And then we'll be checking that if dpi is not equal to 0, dpi sorry, not equal to 0, we'll be returning dp ind. And then from here our main logic will start. Let's have a variable index, and here we'll be performing a binary search to find the next element which we can choose, arrays dot start time, arrays dot binary search, sorry, you can just simply write the binary search function also, binary search. And here what we'll be doing, we'll be passing the start time array, and what we have to do, we have to pick up the index which is we have to pick up the start time which is greater than or equal to the ending time of the last job. So job ind, and here 1, because in the job array we are at the first index of the every ith in the job index we are storing the end time, so we have to pick up an element in the start time which is greater than or equal to the ending time of the previous one. Okay, okay, yeah, it should be here. Okay, so now what we are having, we are basically having two options to pick up the particular element, that will be equal to, if we are picking up the particular element, then we have to do job ind and then 2, then plus in the index what we have to do. Okay, here also let's just check one condition, that if the certain element is not present in the particular array, so if index is less than 0, then it will be returning -1. Okay, so then what I have to do, I have to update index equal to minus of index and then -1. Okay, to make it in the boundaries. Okay, so if we are choosing that particular element, so what we have to do, we have to do find with the next possible index, then find, oh sorry, solve function we are doing, solve, and in the index we'll be passing a job array. Okay, then the start time array, the size of the array, and the dp array. Okay, and the other option is we are not picking up that particular job, so that will be equal to simply find with and we'll be simply moving to the next index, so ind +1. Okay, not find, again solve ind +1 comma job array comma start time array comma n and the size of the dp. Okay, and at the end what we'll be doing, in the dpi will be storing the maximum of pick and not pick, dpi equal to math dot max pick comma not pick. Okay, so now let's run it. Okay, is expected. Okay, so this comparator is not working here. Okay, what we can do is, let's just use the comparator, the other one, comparator class dot comparing int, that will be a1. Okay, so now let's run it once again. It was just a mistake. Now let's run it. Cannot find symbol, COMPA. I guess there's a spelling mistake again, COMPARATOR. Okay, sir, sorry, DPIND. Okay, so I made some mistake. Okay, so we are having the n equal to start and fill dp in, and that how will be update. This is correct. This part is also correct. Comparing, not comparing it. A1 where is dot sort start time, and we have to return 0 start. Okay, so if index becomes greater than or equal to n, we have to return 0. If dpi and not equal to minus 1, return dpi int index. Let's just do it the index job int and then 1. If index is less than 0, I'm updating the index, and pickup is equal to job i2 plus the next index, which you can solve index job start time and not be equal to. Oh, okay, so what I'm feeling is it's return minus 1. So, okay, not equal to minus 1. Sorry, not equal to 0. Okay, so there's still some error. Okay, if I'm not equal to minus 1, I have to run if and index equal to binary search. And if my index is not present, so I have to do index equal to minus index minus 1 first to make it 0 based indexing, then int pickup equal job index at 2 plus solve index job start time and dpr. If I just don't pick it, then I'll just doing simply index plus 1, current index plus 1, then job and start time. Okay, so the error in this case, yeah, let me just try to solve this. Okay, so after like wasting a lot of time, I found out that the logic was having some of the errors. That in this case, if we are saying that in the second case, test case, which is basically failing, is that when we are having start time the same, so what we have to do, then we have to sort them on the basis of the profit, that the one which is giving us the maximum profit. So here we can't just simply solve basis on the end time, but if end times are equal, then we have to sort them on the basis of their uh, sorry their profits. Okay, so in this, let's add another if condition, that the two arrays that are being passed, that if a0 is not equal to first for this case, that if the start time is not same. Okay, if a0 is not equal to b0, then what we have to do, we have to return a0 minus b0. Okay, so then if this is not the case, then we have to check that else if a1 is not equal to b1, a is not equal to b1, then we have to return okay, return a1 minus b1. Or if both the cases are same, like we are having two jobs whose start time and end time both are same, then we have to return the one with the maximum profit. Else we have to return a2 minus b2. Okay, so now let me just run this again. Which is there is some, oh okay, sorry, a comma b, not a minus b. Yeah, and now it works perfectly fine. Okay, so now let's submit it. And it works perfectly fine. Okay, so yeah, so this was it for today. Thank you for watching.